All right, so let's talk about geometric series with variable terms. And what I mean by that is this compared to this. All right, this kind of series we've seen already. Every term is a definite number. So you do the math, you get a half, and then a fourth, and then an eighth, and then a 16th, and so on. Versus something like this where what I'm saying about the x there is that, like, always in algebra when we use x, it's some kind of unknown. It's a number that's not given. It's variable, but that's the difference between an x and 1/2, all right? Okay, here's another analogy. It's sort of like the difference between 2 times 3 plus 4 is 2 times 3 plus 2 times 4. That's pretty easy to verify. I mean, what's that, 14? And then this is 6 plus 8, and that's 14. But if I wrote it this way, A times quantity B plus C, it would be a little bit harder for some people to understand. When I teach algebra, people are normally fine with numbers, but as soon as you start writing letters down, everything gets more complicated. But these two are really the same thing, and so are these, okay? All right, so that's how I want you to think about the x. Why would we do that? Well, so part of the reason that we're learning about series is because, some people who take calculus 2, who want to be engineers and so on, go on to take a class called differential equations, and differential equations are a technique used by engineers and some scientists. It's a very big field, lots of applications to it and so on. But once you start learning the techniques, it does involve series quite a bit, all right? And then these series have variables in it. I don't see that those numbers are constants. It says the sum from 0 to infinity, a sub n times x minus x sub 0 to the nth power. And I would imagine that things like this would look fairly intimidating at this point, but that's part of the reason that we're learning about series now, so that when you go into whatever the field you're going to go into, whatever quantitative field, certain engineers and scientists need to know a lot about differential equations. And we're building up to that by learning about this. Okay? So, how about this? Here's my question for you. See that series right there? Sum from 1 to infinity, x to the n power, which is x plus x squared plus x to the third, and so on. What does the x need to be for that series to converge, and what will it converge to? Well, one thing I notice about this series right here is that it is geometric. Is it true that any term times x will give you the next term? That's what a geometric series is that any term times some fixed number is going to get you the next term. Well, in my case, that's going to be x. So this is a geometric series. The common ratio is equal to x. All right, so let's notice that about this. Well, what does x need to be for the series to converge? In general, a geometric series converges if r is somewhere between -1 and 1. So it's pretty easy to say then that that series will converge if r, which is this unknown value x, is between -1 and 1. And what will it converge to? Well, it will converge to, didn't we have a formula for geometric series to figure out what they converge to? The sum was the first term, which is x, over 1 minus r, which is also x. All right. So that's an abstract question, but that's the kind of thinking that we're going to have to adapt to. All right, you already know about geometric series. Hopefully you can already realize that this is geometric. And my answers to this question just follow from things that we've already learned about geometric series, okay? Let's look at one a little more complicated. How about this one, okay? It has an unknown in it also. I cannot actually tell you, what the partial sums are. Like here I can say sum of the first two terms is 3/4. But I can't really tell you what the sum of the first two terms is here because x is an unknown, all right? I can tell you it's x plus x squared, but that's about it. So this one, like my example I just did, every term is unknown because the x is unknown. All right? Okay, so it looks something like this. First term is 4 times 1 plus x over 2. What's the second term? 4 times 1 plus x over 2 squared. Hopefully you get the idea, okay? So what does x need to be for that series to converge, and what does it converge to? Well, all right, this is another geometric series, isn't it? Isn't it true that you can write more of this out if you want to, but if I multiply any term by 1 plus x over 2, I'll get the next term, okay? So we can say for sure it's geometric. We can say that r is 1 plus x over 2. We can say it will converge if r, like all geometric series, is between -1 and 1. Okay? I'll solve this inequality for x to tell you what the x needs to be. What does that unknown, see that number right there? What does it need to be, or what can it be for this series to converge? Well, so how about this? I got that 1 right there. I'm going to try to solve for the x. I'll subtract 1 from all 3 parts of this. I'll get -2, I'll get x over 2, and then I'll get 0, right? Okay, subtract 1, subtract 1, subtract 1. Then I'll multiply all 3 parts of that by 2, and I'll get -4 and 0, okay? So we're going to need x to be between -4 and 0. What will it converge to? All right, so it will converge if the x is between any number you want between -4 and 0. And it will converge to, what was that formula? A geometric series will converge to the first term over 1 minus r. That's what a geometric series converges to if it converges. So the first term is this, 1 plus x over 2 over 1 minus r, and we said r was 1 plus x over 2. Okay, so that's what it will converge to. Let's simplify it. So this top part, I don't really see the need to do anything with that yet. Here, the 1's will cancel, and this will be negative. Okay. So from here, I'm looking at 4 over 1 plus x over 2. And if I divide by this, that's going to be -2 over x. So let's do this. Let's say -4, 1 plus x over 2, sorry, -8, I'll multiply the 4 and the 2 together, and then divide it by x like that. Okay, and I could leave it that way. I think that that will work, but I could also do, in here, seeing as both of those terms get divided by that, 1 over x plus 1/2. All right. Okay, so I'll give you that one, though. It's a little simpler than the one that came before it. Divide 1 over x, divide x over 2 by x. The x's cancel. So let's say we need this, and if that's where the x is found, and you calculate that series out, it will converge to, what was that number? -8, 1 over x plus 1 over 2. Okay. So, all right, I got my answer. I told you what x needs to be for the series to converge, and I tell you what it converges to. Neither of those are definite numbers. I'm just using the properties of a geometric series. I'm just using the fact that I know what R needs to be for this series to converge. That's this part. And then also because it's geometric, I know what it converges to because there's a standard formula to figure that out.